Hi everyone, welcome back to Technical Mathematics lectures conducted by Vadhyar Online Academy. In this video, we will continue with calculus, and in particular we will focus on the topic derivative of a function. So let's get started. Let's begin our discussion by looking into the definition of derivative of a function. A function f of x is differentiable at the point x equal to a if limit x tends to a f of x minus f of a divided by x minus a exists. So this is the condition to be satisfied by a function f of x to be differentiable at a point x equal to a. Now the derivative of the function at the point x equal to a is given by f dash of a equal to limit x tends to a f of x minus f of a divided by x minus a. So the value of the derivative of the function at the point x equal to a is represented as f dash of a, and it is given by this formula. Okay, now if you are plotting the function f of x in the xy plane, then the derivative of the function at the point x equal to a represents the slope of the tangent drawn at the point x equal to a. So this is the curve of f of x, this is the point x equal to a, and this is the point on the curve where x is equal to a. And if you draw a tangent at this point, then slope of this tangent will be equal to the value of f dash of a, that is derivative of the function at the point x equal to a. Okay, now with this definition in mind, let's have a look at derivatives of standard functions in mathematics. So let the function be f of x and its derivative be represented as f dash of x. Now when f of x is equal to c, a constant, its derivative will be 0. Now a into f of x will have a derivative which will be equal to a into f dash of x. So f of x is a function in variable x and a is a scalar. So in that case, the derivative of a into f of x will be equal to a into f dash of x. Okay, now derivative of x raised to n is n into x raised to n minus 1, and derivative of e raised to x is e raised to x itself. Okay, now let's see another set of derivatives. F of x, when it becomes log x, f dash of x will be 1 by x. That is, derivative of log x is equal to 1 by x. Now derivative of 1 by x raised to n, it's equal to minus n divided by x raised to n plus 1, and derivative of root x will be equal to 1 by 2 root x. Okay, now let's have a look at derivatives of standard trigonometric functions. Derivative of sin x is cos x, derivative of cos x is minus sin x, derivative of tan x is secant square x, and derivative of cot x is minus cosecant square x. Derivative of sec x, it's equal to sec x into tan x, and derivative of cosec x, it's equal to minus cosec x into cot x. Okay, so you must be familiar with all these derivatives. Okay, now let's proceed to the next set, that is derivatives of inverse trigonometric functions. If f of x is sine inverse of x, then f dash of x will be 1 by root over 1 minus x square, and derivative of cos inverse of x will be equal to minus 1 divided by root over 1 minus x square, and derivative of tan inverse of x is 1 by 1 plus x square. Okay, so these 16 formulas are very fundamental equations in derivatives of standard functions. So please by heart all these formulas. Okay, now based on these formulas we will solve few practice problems. Let's go to problem number 1. Find derivative of the function y equal to e raised to x minus x cube plus cos x. So we are asked to calculate derivative of the function y equal to e raised to x minus x cube plus cos x. So a simple problem. Let's find out the derivative. Y dash will be equal to, here we have to find out derivative of each of the terms present on the right hand side. So the first term is e raised to x, derivative of e raised to x is e raised to x itself. So e raised to x minus derivative of x cube will be 3x raised to 3 minus 1, that is 2. So x cube will have a derivative which is equal to 3x square. Then plus we have cos x here, derivative of cos x is minus sin x. Okay, so here the derivative of the function y dash or dy by dx, it's equal to e raised to x minus 3x square minus sin x. Okay, so this is the answer. So it's a simple problem just to familiarize the differentiation. Okay, now let's move on to problem number 2. Find derivative of the function y equal to x raised to 2 by 3 minus 2 sine inverse of x plus 8. So again we have to find out y dash or dy by dx. So let's try to find out derivative of each of the terms present on the right hand side. So here the first term is x raised to 2 by 3. So derivative of x raised to 2 by 3 will be 2 by 3 into x raised to 2 by 3 minus 1. Okay, then minus 2 into sine inverse of x. So this is in the form a into f of x. So 2 is a constant, so we may write it as such, 2 into f dash of x. That is, here the function is sine inverse of x. The derivative of sine inverse of x will be 1 by root over 1 minus x square. Okay, now plus 8. So derivative of 8 will be 0. 8 is a constant, so derivative of this term will be 0. Okay, so we are getting y dash or dy by dx as 2 by 3 into x raised to 2 by 3 minus 1. So we will get it as minus 1 by 3 minus 2 into 1 by root over 1 minus x square. So that we can write it as 2 divided by root over 1 minus x square plus 0. Okay, so here the derivative of the function y is given by y dash equal to 2 by 3 x raised to minus 1 by 3 minus 2 by root over 1 minus x square. So that's the answer. Okay, now let's have a look at product rule in differentiation. Suppose we have two functions u and v defined on the variable x, then d by dx of u into v, that is derivative of the product of the two functions, will be equal to u into d by dx of v plus v into d by dx of u, that is the first function into the derivative of the second function plus the second function into the derivative of the first. Okay, to familiarize this, let's do one problem. Problem number 3. Find dy by dx for the function y equal to e raised to x into sin x. So we are asked to calculate derivative of the function y equal to e raised to x into sin x. Okay, so here this e raised to x may be considered as one function, that is u, and sin x may be considered as another function, that is v. So as per product rule, d by dx of u into v is equal to u into d by dx of v plus v into d by dx of u. So here dy by dx will be equal to e raised to x into d by dx of sin x plus sin x into d by dx of e raised to x. Okay, so this implies that dy by dx will be equal to e raised to x into d by dx of sin x is cos x. So e raised to x into cos x plus sin x into d by dx of e raised to x. So that is e raised to x. So this is the derivative of the given function. Now on the right hand side we have e raised to x common in both the terms. So we may rewrite it as dy by dx equal to e raised to x into cos x plus sin x. Okay, so this is the answer. So this way, by making use of product rule, we may solve problems like this. Okay. Now let's discuss about quotient rule in differentiation. Suppose we have two functions u and v defined on the variable x, then d by dx of u by v, it will be equal to v into du by dx minus u into dv by dx divided by v square. Okay, so this is what quotient rule says. So the given function, if it is in the form of a ratio of two functions, then we may make use of the quotient rule to find out the derivative. Okay, so let's see one problem. Problem number 4. Find dy by dx for the function y equal to cos x by 1 plus x square. So we are asked to calculate derivative of the function y equal to cos x divided by 1 plus x square. So this is in the form u by v. Okay, here u is cos x and v may be considered as 1 plus x square. Okay, so let's make use of quotient rule. So dy by dx will be equal to 1 plus x square into d by dx of u. U is cos x, so d by dx of cos x minus u into dv by dx. U is cos x here, so cos x into d by dx of v. V is 1 plus x square here, so d by dx of 1 plus x square whole divided by v square. V square is 1 plus x square the whole square. Okay, now let's simplify this. This implies that dy by dx will be equal to 1 plus x square into d by dx of cos x is minus sin x. So this one minus cos x into d by dx of 1 plus x square. So that will be derivative of 1 is 0 and derivative of x square will be 2 into x raised to 1. So that is 2x. Okay, so this is the numerator term, that one divided by 1 plus x square the whole square. Okay, so let's rewrite it as dy by dx equal to 1 plus x square into minus sin x. So that will be minus sin x minus x square into sin x minus, here we have cos x into 2x, so that may be written as 2x into cos x whole divided by 1 plus x square the whole square. Okay, so this is the answer. Okay, so the given function is y is equal to cos x by 1 plus x square and its derivative is dy by dx equal to minus sin x minus x square sin x minus 2x into cos x divided by 1 plus x square the whole square. So we are finding out the derivative by making use of the quotient rule. Okay, let's see another problem. Problem number 5. Find dy by dx for the function y equal to x into cos x divided by e raised to x. So in this problem we will have to make use of both product rule and quotient rule. Let's see how to calculate dy by dx. So dy by dx will be equal to, as per quotient rule, dy by dx will be equal to v into du by dx minus u into dv by dx whole divided by v square. Okay, so let's take u as x into cos x and v as e raised to x. Okay, so this implies that dy by dx will be equal to v, that is e raised to x, into d by dx of x into cos x minus x into cos x into d by dx of e raised to x whole divided by e raised to x whole raised to 2. Okay, now this implies that dy by dx will be equal to e raised to x into, here we have d by dx of x into cos x. So here we have to apply product rule. Okay, so we will get the derivative as e raised to x into x into d by dx of cos x, that is x into minus sin x plus cos x into d by dx of x, so that is 1. Okay, so we get the first term as e raised to x into x into minus sin x plus cos x minus x into cos x into d by dx of e raised to x, so that will be e raised to x itself. So we get x into cos x into e raised to x whole divided by e raised to x whole raised to 2. Okay, now let's simplify this. By simplifying, we will get dy by dx equal to, okay, here we have e raised to x, here also we have e raised to x, here we have e raised to x whole square. So we may cancel 1 e raised to x from both numerator and denominator. So we will get it simplified as x into minus sin x plus cos x minus x into cos x whole divided by e raised to x. Okay, so if we rewrite it, what we get is dy by dx equal to 1 minus x into cos x minus x into sin x divided by e raised to x. So this is the answer. So we are getting this answer by applying quotient rule as well as product rule. Okay, so with this we are coming to end of lecture 21. In lecture 21 we discussed about the definition of derivative of a function, then we discussed about derivatives of standard functions, and following that we discussed about product rule and quotient rule in differentiation. Okay, in the next lecture we will discuss about chain rule and implicit differentiation. Okay, so see you in lecture 22. Goodbye.